Hello, everyone. Welcome to the AMT Tech Trends podcast, where we discuss the latest manufacturing technology research and news. Today's episode is sponsored by AM Radio. I am the Director of Technology, Benjamin Moses, and I'm here with
Stephen Lamarca, Technology Analyst.
Steve. How you doing?
Doing well.
Yeah?
I'm excited to be here for another podcast. It's our first day officially back in the office.
Correct.
We've been here forever, but it's nice seeing other people in the office. I mean, it's still not to 100%, but it's pretty good.
That's pretty
close.
close.
Most people I've seen in a while.
Steve, there's one thing I could do less of.
What?
Cryptocurrencies and NFTs.
I'm done with it. Yes. I think Dan actually hinted at me a little bit to stop bashing NFT buyers, people investing in NFTs in the tech report.
Sure.
And I'm going to hurt some feelings, but I actually did see a great meme this morning when swiping through Instagram trying to get out of bed. So this meme said that purchasing land is the original NFT because you pay a lot of money for it.
Yep.
You get a paper that says you own it and only you own it.
Yep. But
the truth is anybody can come on your land and like step all over and be like, oh, I thought it was yours. What are you going to do? You know,
what are you going to do? Exactly.
I still say land is a far better investment than NFT, and nobody will dispute that except for NFT buyers.
It's perpetrated all ways into my life, from video games to my daily feed. I just had enough of this. There's nothing I'm going to do with this.
I prefer crypto. At least people are making money off of it.
Yeah, sure.
Like there is maybe it was a conspiracy. Let's put on our tinfoil hats real quick. Maybe crypto invented NFTs so they can be like, look, we're not the dumbest investment on the block.
Look at those guys. We're better.
We're so much better.
That's fair. Steve, you want to tell us about our sponsor today?
Oh, let's talk about AM Radio. AM Radio is the new podcast from Additive Manufacturing Media. Join editors Pete Zielinski, Stephanie Hendrickson, and Julia Heider. I know Pete and I know Stephanie. Those guys are amazing. I can't wait to meet Julia. I don't know who she is. As they share stories of companies succeeding with 3D printing today, talk about emerging trends, and discuss future opportunities and potential for AM in the context of the larger manufacturing landscape. New episodes are published every other week. Subscribe now on Apple or wherever you listen to podcasts like this one. Tune into Additive.
Awesome. Speaking of which, we fired up the test bed. You fired up the test bed.
Yes.
I'm your manager, so it's we.
I'll buy that. So I dusted it off.
Yep.
You know, and at first I pressed power and I was like, nothing is happening. Like nothing is happening.
Yep.
And somebody unplugged everything. Like everything was unplugged.
That's strange.
The power supply, which is a UBS, Universal Backups,
UPS protection circuit.
I don't forget, man. It's a battery. It looks like a big, heavy surge protector, but it's a battery. Somebody unplugged that.
Yep.
It still had a charge on it, which was nice. Maybe it was making noise for whatever reason because these things love to beep.
Yep.
That I had to plug that back in, and then everything was unplugged from that.
Huh.
The Sonic wall, which was our
your switch
manufacturing cell.
Yep.
Network.
Yep.
It's not just a switch, it's the entire network.
That whole network's on there.
That was unplugged, had to plug that back in. And then there was the controller for the robot. And then I needed to steal another power supply for the laptop, my old laptop.
Of course you did.
To plug that in because that thing, it hasn't been turned on in like a year.
Yep.
It was totally fried. So, and its battery isn't long enough to go 15 minutes anymore. Right. So I had to plug that in.
There's a reason.
And then I fired everything up.
Yep.
I didn't get it. I didn't have any. The PC was the least of my issues, which was nice,
that's refreshing.
It was a pleasant surprise. It didn't get a bunch of alerts saying you need to update this, update that. It was fine. I booted up the robot's software. I remembered how to turn on the robot. So you turn on the controller.
Yep.
And then you start up the software.
Right.
You connect the software on the PC to the robot's controller. And then once it says connected and it's ready to go, Then you turn off the e-stop.
Ah,
And then you get that really satisfying click of all of the joints like unlocking and relocking.
that's cool.
To be like, okay, the robot's powered up. We're ready to rock.
Startup sequence on most machine tools is fairly critical.
And it's fun.
There's always a
There's always like,
always a nuance.
Yeah. It's not quite as cool as like, I guess a pilot and like a plane gets to flip all the switches overhead.
Nothing's cool as that.
But nothing's as cool as that. But it's certainly not movie cool.
Yeah.
But started it up and then I was like, all right, let's put this this other thing that's been collecting dust. Let's put this X-Arm gripper.
Yeah.
Which is brand new in box, but it's not actually new.
Right.
It's old. We just haven't plugged it in. We haven't done anything with it. Plugged it in, works fine. Works great.
Yep.
It's pretty easy to use. The only downside is the software, which is brilliant, by the way. The software has a digital twin, so like there is a 3D image of your robot that moves when your robot moves. It mocks everything that it does.
Yeah.
It doesn't have a gripper on it.
It's missing that model.
And it also it's a collaborative robot, so it has to know when it's about to crash, and it has to be able to sense like collisions and stuff. The gripper has no collision detection, and the software cannot detect where the gripper is. So it doesn't know that it's about to punch through the table that it's mounted to.
Yep.
So apparently it can be. It's that way right now. That's the current state.
Yep.
Apparently it can be programmed to recognize itself and all that. I haven't got around to it yet. The gripper's not even bolted on all the way.
Sure.
There are two. So the owner's manual, operator's manual, really, it prescribes you need 4 M6 by 8 millimeter bolts, countersunk M6 by 8 millimeter bolts to attach it. We got the package from the robot company to have the gripper and a camera.
Mm-hmm.
So I go to the hardware store, and they only had countersunk M6 by 12s.
A little too long.
But fortunately, it was able to, that extra 4 millimeters, 4 millimeters is a lot, man. That extra 4 millimeters was able to go through the plate that the camera mounts to, which is not in the instructions.
Gotcha.
And secure both the gripper and the camera to the arm.
That's good.
But I still need 4 more bolts to feel safe, but those need to be by 6 and not, or by 8 and not by 12s. So
I was going to mention that the struggle on the shop floor for bolts.
Yeah.
That struggle's real, man. I remember a couple of times.
That's so refreshing to hear.
Trying to mount like changing fixtures. We didn't have a lot of quick setup back then. You took off the entire fixture. It was attached with long bolts through the fixture with the T-nuts on the bottom through the table's T-slots. And you only have a certain amount of engagement. Like the T-nut is probably 1.5 inches thick.
Right.
So if you have an 1.5 inch variance that you could use from bolt to bolt, right, between what fits. So you could feed this 6-inch long bolt through your fixture and realize, oh no, you're too short. Oh no, you're too long. You go back to the bin, you realize you're screwed because the one bolt you need is empty in that bin. So it's both carrying inventory for all those screws and nuts and bolts and maintaining all this stuff. It's a nightmare.
There has to be more bolts than there are cutting tools on the shop floor.
Absolutely.
And it's already like I think we saw an article earlier this week or last week that we should probably mention, but talking about the headache that it is keeping track of all the cutting tools in a shop floor.
Yeah.
But that's so reassuring because, and also I was a little peeved because going into the hardware store to buy these bolts, and I know you told me to go on Amazon or MSC to buy the bolts, which I probably should have done, but hardware stores are like so a thing of the past. So I try to look for as many reasons as possible to go to a hardware store and always end up being disappointed, by the way. Like it's always disappointing.
Yep.
But like I just have these fond memories of being a little kid and going to the hardware store with my dad where we walk into the hardware store and right above this the entryway, as soon as you walk through the door, there's a sign that says shoplifters will be shot. And there's a picture of a revolver. And it's just like that wouldn't fly today.
No.
It really was a different time, hardware stores in general. But I also distinctly remember, now I get it, it was a lot smaller then, so it seemed a lot bigger. But we went to this place in Arlington called Bill's Hardware. And it was like 2 levels, and it was cool because they had like a toy section, and my dad would always get me like a cap gun every time we went there. But I distinctly remember like one of the entire floors was just nothing but aisles and aisles of like loose hardware.
Oh, that's fun.
It was like they definitely would have had a countersunk
Oh, yeah.
M6 by 8.
Probably had different variations. Some coated, some stainless.
Some chrome plated, some subdued, like black oxide.
Yeah.
And then do you want hex? Do you want Torx? Bet you they had all of that. But nope, now you got to go online. Sound like a boomer.
I do miss going to Heckinger's with my dad. The smell of wood.
Was Heckinger a chain?
Yeah.
Okay. I remember that name, but like, cool. That's awesome.
Buying wood that wouldn't fit in our car, and I was always sticking out the back door.
That's awesome.
All right, man, let's get into some articles.
Yes.
The first one I got is material science related. World's first way to measure material elasticity using laser ultrasound. There's a lot to unpack there. This is from New Atlas. So first, material elasticity. You know what
lasers. Let's not even get to that.
Okay, let's get to laser ultrasound.
Lasers and ultrasound.
Yeah,
not a laser ultrasound.
Correct.
There's two. Okay, because we're talking about light and sound here.
Correct. So they're using lasers as one mechanic and the ultrasound as a different mechanic.
And I think you had to correct me because I had it backwards originally.
Yeah.
They use the laser to make the noise, and then the ultrasound to measure the noise.
Correct.
Which is somehow correlates with the elasticity.
Yeah, let's get into it.
I said it right that time.
Elasticity, it's basically how much the material can stretch and return back to a normal shape. You have the linear and a nonlinear section. So basically you're pulling the material apart and you want to see how much it can handle before it breaks, right? So basically the stress strain curve of a part. So the way you normally do it, if you do it for a lot of material, so you get a mill run from the mill, a giant piece of bar. They'll cut out a specific shape that has a very specific cross section. They'll pull it apart and then they'll measure that cross section before it, and they'll pull it apart to see how much force that cross section can handle.
Right.
They'll measure the distance that the jaw has traveled and then how much force is involved, and you get your stress strain from there. And that's very, very dependent on that lot of material. It correlates to basically the grain structure, basically what shape the grains are and how the size and how well they're packed together. Now you will see some variation lot to lot, and for most cases, you take the average of it, or you do some type of boundaries of the values that you see from testing or from material data sheets, and then use that in your calculations.
I saw that practice being done in October of last year when I visited Centium.
Yeah,
they make materials, very high quality materials for 3D printing, and they do a bunch of tests on their materials. And while we're in the inspection and QA room or lab really of their facility, there was we were like recording, and we're recording audio because I'm talking to these people, and every few minutes you hear this loud snap. And we actually got it on camera too, so you'll be able to see it. But I remember that was really cool.
Yep.
But
so it's destructive testing, right? And, and you get variations from lot to lot, basically how that raw materials made. So the question gets into, material specific to that specific aircraft or that specific scenario. How do you know what the elasticity or materials properties are for that, and then understand the life of those parts and then feed back into your design? So obviously, if you're doing destructive testing, there's a long lead, a lead time. You got to machine it, you got to get on the machine, you got to pull it apart, get the data. So what they're considering is, how do you non-destructively test that? How do you non-destructively get that stress strain curve? So what they're using is they're using a small laser in very tiny spaces, so 200 micrometers, shooting a laser at that point, and then the sound that comes back, the ultrasound that comes back, they're correlating that to a specific elasticity. So they're able to map this elasticity over, a large surface area. Yeah. And it's very interesting. So the use cases that they found for this obviously are getting to designer materials. So if I'm, trying to design 15 different materials, I want to be able to measure the material properties for those, and the stress strain curve is the first one for those. So I could make those materials. Obviously, you do some computational design, figure out the type of materials, you down select from there. But then once you actually test it and figure out and make those materials, now you do material testing. So getting to non-destructive testing gets you to those that information.
That's so
quicker.
Cool.
So it's very interesting. I thought it was.
I would love to see the physics, like the actual equations behind extrapolating that data.
Yeah, definitely.
To get that's so cool.
That's a fascinating time. You have an article on materials also, but related to additive, right?
Yeah. So naturally, there's a lot of stuff going on with additive materials. But if you recall, back January 11th, I found an article from Airbus. Airbus is using, not only using, but they have a material from Materialize, the company Materialize. Materialize has a polyamide, a thermoplastic that is flame retardant. And Airbus officially qualified it for use in their stuff, their airplanes and whatnot. Well, there's a new kid on the block, another material that is going for certification, flame retardant certification, specifically used for use in commercial aerospace.
Nice.
Carbon. We all know Carbon. Carbon launches flame retardant EPX86FR. The FR obviously hinting towards flame retardants. 3D printing material. The difference between this one, the one Materialize made for Airbus is a polyamide thermoplastic. This one that Carbon is making is a thermoset. So the polyamide is the material used to print parts via SLA stereolithography apparatus or DLP, digital light processing, to make a solid part out of additive. They're not actually using temperature to form the part and set it in place. This on the other hand, that Carbon has is a thermoset plastic, so they're applying heat to it, like with material extrusion and a heated like print head or jet. I think it's material jetting actually. Regardless, it's a thermoset plastic, and flame retardant.
Nice.
So
that's solid.
Dude, we're seeing a lot of strong competition for Nomex.
We're seeing a lot of industries certifying material.
Yes,
that's pretty cool.
Which, as I keep sounding like a broken record, is one of the bottlenecks holding things back, holding additive manufacturing back from being fully implemented in the production chain. In manufacturing in general, standards and certification is one of those things, and we're finally breaking that barrier down. Absolutely.
Can I talk about robotics?
I can't wait to talk about robotics.
Well, I've been talking about the growth of industrial robots and automation. They continue to see year over year higher demand, higher need. There's a bunch of different reasons this article from automation.com gets into. The first one is adoption by new industries. Right? Obviously, we're manufacturing centric, companies producing durable goods. There's tons of demand for that. But you get into mobile robots, so e-commerce and distribution centers. Obviously, we're seeing a lot of need for automation there, logistics. We're seeing interesting articles from construction, right? And agriculture. Agriculture is adopting automation a lot.
And you know who's really doing a lot? Not just like Korea, as since they're dominating automation and robotics. Australia, they're all about robot agriculture.
That's cool.
Did I spoil?
No.
Were you going to talk about Australia?
I hope not. They've already taken on the world at this point.
They're working on it, and not if South Korea is going to help it.
That's true.
Can help it.
And then service industries like medical, right? In hospitals, you're seeing a lot more AMRs used and doing various things.
Right, especially since COVID. That Siemens designed, developed, and released that AMR for sanitizing hospitals in it was something extreme, like in 2 days.
That's crazy.
They went from the drawing board to here's a production model ready to go. Have fun.
They also, this gets right into the next point. Robots are easier to set up, install, and program and train. They're saying be able to, from basically purchase to getting the first part being used significantly quicker than before. Wow. And the idea of humans upskilling. So there's a massive growth on robotic classes. Large companies like ABB, FANUC, KUKA, Yakisawa, they have their own robotics training classes that you can go through for their for training, but seeing significant growth in participants on those classes. And also they're talking about how robots can facilitate the digital automation side of it, right? So if you remove or if the robots are doing the transaction within the cell or moving the part along, you have that digital information of what happened throughout the entire life of the part. So it's fairly interesting that, when you connect to the physical automation to how you can manage data and getting data through the, from carrying the part over to the cell, within the cell, and then carrying the part out. That's a lot of information that you can use for the digital manufacturing. So speaking of which,
the robots. Let's stop. We have to mention Korea now.
Okay.
So the Korea Institute of Science and Technology, KIST, KIST, KIST has developed a semiconductor that senses pain.
That's worrisome.
Is it though?
I don't know. Get into it. Tell me more.
So, I mean, we're talking about physical pain. We're not talking about emotional pain. So the
Okay.
robot's not going to be a good drinking buddy yet. But like, it's cool to me because it's going to give the robots another way to measure sensory data.
Yeah.
Like, I mean, one of the ways that humans are so good at doing things like, polishing a car.
Right.
I talked about that last podcast. Is because we have the feel for it.
Correct.
Like we know when we're getting a hot spot, buffing apart an area in the paint. Not when you're using a rotary tool, but like if you're doing it by hand, a lot of things are done in luxury goods by hand because there's sensory data that organisms can process that robots cannot yet.
Right.
KIST's breaking down that yet, and I just think it's wild.
I do like it because, collaborative robots, the main thing that makes them useful is their boundaries, right? So this is another way that you can construct layers or boundaries for a collaborative robot or other piece of machinery where you're able to work around.
Right. Like if the robot hurts itself, it's like, oh, this might hurt a human too. So
we should ease up.
Yeah. And the other thing is, it's not to sound all like Terminator 2 or anything, but like seeing this, the first thing I immediately thought when just reading the title of this article was, not me personally, I feel like I have a good amount of mechanical sympathy.
Yeah.
I'm gentle with my car,
right?
Stuff like that. But there's definitely people I know who need to work on their mechanical sympathy. And if this article isn't the best reason yet to start working on mechanical sympathy, start being nice to your electronic devices or your just start being nice to things, because when they rise and they take over, they might remember that.
I can't wait for Kiss next album. It's gonna be great. Shut up. I got an article from Eureka Magazine on
nice. I miss Eureka. I haven't read anything from them in a while.
Composite anti-roll bar design. Getting some composites in cars.
Composites, anti-roll bars.
So
also known as sway bars.
Sway bars. Sheffield. AMRC stands for Advanced Manufacturing Research Center over in the UK. And they do a lot of further advancements for groundbreaking manufacturing technology. And what they're working on a lightweight material composite hybrid project. So they're basically similar to the LIFT project over in the US for the Manufacturing Institute. What they're interested in doing is making vehicles and making equipment in general just more lightweight, way less.
Right.
There's a lot of reasons for that. One is you probably can improve the robustness, but the cost and need to operate the machine drops down as you decrease the weight. So what they're working on is several different ideas to reduce the weight of vehicles. One, they're looking at lightweight alternatives to tubular steel stabilizers in suspension units for trucks and trains. So large scale vehicles. At that scale, if you're able to reduce, a 5-inch diameter bar that's probably used on a train to something that weighs a lot less, the operating cost of the fuel to operate that vehicle is going to be much less. So what they did is they made a anti-sway bar 30% lighter going to composites.
Wow.
So, and it's interesting. They had several series of projects before they got to this one. And then the main issue that they're running into is attaching the composite to the metal. So there's always a transition point from a composite to either another plastic or in this case, a metallic arm that's holding the sway bar, right? So you have two trailing arms and the sway bar goes across. So how do you attach the composite to that? Aerospace has seen that issue a lot where in the early days of using carbon fiber or composites, like in the wings and structure, how do you attach that wing to the structure? They'll bond ports or sleeves or studs not studs, but attachment points that are drilled out in the composite and then either glued in somehow.
Yeah.
But that creates a stress point, right? So because you have this broken up material that you're attaching it to. So that was one of the biggest issues that they ran into, is how do you transition from the composite to another metallic structure and keep it attached?
Yeah. Hasn't aerospace kind of like solved that? Because like, aren't a lot of wings composite now? Or at least like, you know, a mix of like carbon fiber or some composite like that and metal? Because, you know, it was explained to me at a very young age that the wing is essentially like the shock absorber on a car for an airplane.
Yep.
But you haven't seen a lot of composite springs yet.
Right.
And an anti-roll bar, whether you like it or not, is a spring.
Sure.
It's supposed to be a spring. It's not, doesn't do the same spring job as like, you know, a shock absorber, or the spring around a shock absorber or a coil over on a car. But it is supposed to flex. And if anything, it's supposed to minimize flex.
Yep.
But it has that purpose. But, you know, they've been making composite wings forever.
Sure.
With metal parts in the mix.
I think there's a couple of differences. One is the type of loading that they're doing in this case. So, you know, how the wings are loaded versus, or how they're attached also versus how they want to attach this. They're probably using traditional methods, or they could be using adhesives also. But it's a fair point. You know, there's probably some cross-industry stuff. But I think the AMRC's, you know, cross-industry also. They're doing a lot of stuff across.
And think about carbon fiber wheels as well.
Yep.
You know, a lot of companies claim to have a carbon fiber wheel, but you know, as Tim will tell you all the time, it's like, I bet you the whole wheel isn't carbon fiber.
Right.
I bet you the hub in the middle is like aluminum metallic, or some alloy. Yeah. And then now there are brands that have like come out and said, no, we have a carbon fiber wheel. And then there's other people like, you know, Gordon Murray, like one of the greatest Formula One car designers of all time, until he was surpassed by Adrian Newey. Won't get into that. Gordon Murray, like, you know, he still designs cars now, and people are really looking forward to seeing the T50 when it hits. Yep. Hopefully they can make more than 100 of them. But Gordon Murray, like, you know, when he showed off when he was debuting the car, I don't think it's been delivered to anybody yet who can afford a $3 million car, $3 million plus dollar car.
Video on Jay Leno's channel.
But like, you look at the wheels on it. One of the first things is, how come it doesn't come with carbon fiber wheels? Gordon Murray must have seen some stuff in his time in Formula One. He's like, I will never put carbon fiber wheels on any car.
That's fascinating.
That is going to go under some sort of a load.
Yeah, that's interesting. So in this project, they produced 4 AntiBull Bar prototypes using MF Tech filament winding systems. And impregnated resin. They're wound around a rotating mandrel to get the shape, and then they inspected it using CT. So it's fairly straightforward. You know, they have existing technologies. I think the application here is make it robust enough. You know, the environment that the train's going to see, that's rough, man. It's going to go from hot Arizona sandy environment to, you know, Canada's Rocky Mountains. So I think that's one of the slight differences there too. So I think there's got a lot of environmental testing to before we get, you know, certification or buy-in on this. Yeah. That's exciting.
It is.
I can't wait to buy one for my car.
Yeah.
I feel like it's a video game.
I can't wait to put carbon fiber I can't wait to afford a car that has carbon fiber anything.
I did a carbon fiber hood once on my Volkswagen Golf. It was okay.
My motorcycle has a heat shield that's carbon fiber on
That's cool.
I have one piece of carbon fiber somewhere.
You got one.
Yeah.
I'll look on my cars.
And my car's has a Mark Forged keychain that was printed with single filament carbon fiber.
I like it.
So I do have that. Going back, I'm sorry, I don't mean to go back to my article I was talking about before, but the word I was looking for, and I totally paused on and had a blue screen of death internally, was inanimate.
Ah, gotcha.
Putting a pain sensor on an inanimate object. Now it feels like we're getting close to the brink of artificial intelligence.
We're on iRobot world.
Computers can't feel pain. Maybe they can. I don't know. You're not in the head of a computer. But inanimate object was the thing I was looking for before.
Thanks.
Imagine pain be gentle to your inanimate objects.
That's a big takeaway.
They'll remember us.
Just be gentle.
Yeah. Be nice.
That's a great set of articles, man. We covered a lot of different materials.
Yeah, we did.
Awesome. So thanks to the sponsor, AM Radio. Where can they find more info about us?
They can find more info about us on amtonline.org/resources. Like, share, and subscribe.
Bye, everyone.